Welcome to Homework Lib.
Okay, so we're doing chapter 34, problem 103 here. So in this problem, it says we are working at an optics company and we get a diverging lens and we want to measure the focal length. And we know that with a converging lens, we can measure it by placing an object to the left of the lens just far enough for the image to be real and moving it around. But for a diverging lens, we only have virtual images, so we can't really do this. So we determined that you can find the focal length if you take a converging lens and measure where the image forms of that, and then placing a diverging lens in front of that. So let's figure out about how we can do this. So first, let's draw this, and we have a converging lens here. And in the initial case, it says the focal length. Oh, it doesn't give us the focal length. We place an object 20 centimeters to the left. So here, 20 centimeters. And we get our image 29.7 centimeters over here. Awesome. So the first case is we add in a diverging lens right here, 20 centimeters away. And what it does is they then see the final image 42.8 centimeters to the right of the converging lens. So let's write out the stuff for that. So we know where the converging lens image is, which is what we're going to use as our virtual object for the diverging lens. So the object distance here is now going to be 29.7 centimeters minus 20. So, but it's also on the right side of the lens, so we know it must be negative. So this comes out to be 9.7 centimeters. Cool. They told us that the image of this is then 42.8 centimeters to the right of the converging lens, which is the same as 22.8 centimeters to the right of the diverging lens. We can now solve for the focal length as s prime over s plus s prime. If we do that, we see that our focal length is negative 16.88. Cool. So what it also says, we suspect some inaccuracy in this measurement, so we repeat the measurement, but now we place the diverging lens 25 centimeters away. So now our SD becomes negative 4.7 centimeters. And it says from that, the image distance is 31.6 centimeters to the right of the converging lens. So that corresponds to 6.6 centimeters of an image distance. Again, we can plug this in to figure out the focal length, and it comes out to be negative 16.33. Awesome. So we can take the average, and that comes out to be negative 0.61 centimeters. So that's our average focal length, and that's what we take as our best experimental value. Cool. So part B says which position of the diverging lens, the 20 centimeters or the 25 centimeters to the right of the converging lens, gives the tallest image. So from this, we can just figure out which one has the bigger magnification, right? So the first case is given as negative 9.7. Oops, sorry. This is a negative times 22.8 over negative 9.7. That's 2.35. M2, however, is negative 6.6 over negative 4.7. And that comes out to being 1.404. So since the second case has a lower or smaller magnification, the image height is going to be smaller. So the first case with the lens, with a diverging lens 20 centimeters to the right, produces the tallest image. Awesome.